everyone. Today we'll be discussing the composition of mixture. This is the calculation part in your grade 11 unit 3, that is the mixtures lesson. In the mixtures lesson there's a calculation part. Today I'll be discussing that part with you. What is composition? The amount of solute particles in a unit volume of a solution is called the composition. What is solute? You might have heard these words solute, solution and solvent. What is solute, what is solvent and what is solution? Solute is what gets dissolved in the solvent and solvent is the liquid, or else you can tell that solute is in less amount and the solvent is in more amount. Solution is solvent plus solute, we call it solution. There are several ways of expressing the composition of a mixture. In this lesson we will be learning about 5 types of expressing the composition of a mixture. First one is mass fraction, second one is volume fraction, third one is mole fraction, fourth one is mass per volume, and fifth one is moles per volume. Moles per volume is the concentration. Let's consider the first one. Composition of a mixture as a mass fraction. The symbol is m over m. Now let's consider mixture. Now you think there is a mixture. In that mixture is made up by mixing x and y components. This mixture is made by mixing x and y components. Now this mixture is mixed. Now that means you think it is a solution. In this, now somebody is asking me to find the mass fraction of x. Mass fraction of x means what fraction of x is in the particular solution. What fraction of x is in the particular solution. How can I find it? This is the equation. Mass fraction of x in the mixture equal mass of x over mass of x plus mass of y. Now because we have to find the mass fraction of x, the mass of x will come on top. And the mass of the solution, the mass of the mixture, the total mass of the mixture will come down. Here the total mass of the mixture is the mass of x and mass of y. So the total mass of the mixture will come down. Now think that you want to find the mass fraction of y. Then what happens? The mass of y comes on top and mass of x plus mass of y, or the total mass, will come down. We'll see an example. First example, a solution is prepared by dissolving 20 grams of sugar in 80 grams of water. Find the composition of the solution as a mass fraction. The solution is made by dissolving 20 grams of sugar in 80 grams of water. That means in this solution totally there is 20 grams of water plus 20 grams of sugar. They are asking us to find the mass fraction of the solution. When they ask us to find the mass fraction of the solution, we know the equation is composition of mass fraction equal mass of solute over mass of solution. We can take this as mass of sugar over mass of sugar plus mass of water. Here the solute is sugar. So the mass of sugar is 20 grams. And the mass of the solution. Solution contains 20 grams of sugar and 80 grams of water. That means the mass of the solution is 20 plus Example 2. This is a little different from the first one. 20 grams of salt is dissolved in water to prepare a solution. If there is a certain amount of water, we don't know how many grams. We are adding 20 grams of salt into this. And they have given us the mass fraction of this as, they have given as 1/4. They are asking us to find the mass of water. We know the equation for composition of mass fraction. Equal mass of solute over mass of solution. Here the solution is water plus salt. Now from these details we know the mass of the solute. The solute is salt. We know that it is 20 grams. Mass of the solution. Mass of the solution comes from mass of water plus mass of salt. We don't know the mass of water. We'll take it as X. We know the mass of salt is 20 grams. And they have given us the mass fraction of this solution as 1/4. Now we are going to subject this X. I will take this X plus 20 this side. When it comes this side, it comes up. X plus 20 comes up. And I'm going to take this 4 that side. When the 4 goes that side, it goes up. Then 20 into 4. That is 80. X plus 20 equals 80. Then X equals 80 minus 20. X equals 40 grams. The mass of water is 40 grams. Second type, composition of a mixture as a volume fraction. Volume fraction is used to indicate the composition of a mixture when both of its components exist either in liquid state or gaseous state. That means you think that there is a mixture with X and Y components. Both X and Y should be in liquid state or both X and Y should be in gaseous state for us to give the composition of a mixture as a volume fraction. Now I'll give you an example. You think there is a solution, there is a mixture. In that there are X components and Y components. There is some amount of X, a certain volume of X and a certain volume of Y. Now they are asking me to find the volume fraction of X. That means in this solution, what fraction of X is there? What is the fraction of volume of X in this solution? Then how I am going to find it? They are asking us to find the volume fraction of X. So the volume of X comes up and the total volume of the mixture comes down. That means here you can take as volume of X plus volume of Y. If they ask us to find the volume fraction of Y, then what happens? Volume of Y comes up and down same, total volume of the mixture. Example 1. A solution of final volume 250 cubic centimeters was made by adding distilled water to 25 cubic centimeters of ethyl alcohol. What is the volume fraction of ethyl alcohol in this solution? Here they are adding 25 cubic centimeters of ethyl alcohol to distilled water. We don't know the mass of we don't know the volume of distilled water, but we know the final volume. That means the final volume is the volume of water plus ethyl alcohol. They have given us as 250 cubic centimeters. So now we have to find the volume fraction. volume fraction equal volume of solute over volume of solution. Volume of the solute is 25 cubic centimeters. Volume of the solution, they have given us the final volume is 250 cubic centimeters. That means the volume of the solution is 250 cubic centimeters. They are asking us to find the mass fraction. Cubic centimeter cut off. The answer comes as 1 over 10 or 0.1. Example 2. How do you prepare 500 cubic centimeters of an aqueous solution of acetic acid of composition 1 over 25? Here they have given us the composition. Here they have given us the final volume. Final volume means the volume of the solution as 500 cubic centimeters. And they have given us the volume fraction as 1 over 25. We have our equation, volume fraction equal volume of solute divided by volume of solution. Here we don't know the volume of the solute. We take it as X. The solute is acetic acid, but we know the volume of the solution. That means they have given us the final volume as 500 cubic centimeters. And they have given us the volume fraction, this is the volume fraction, as 1 over 25. Now we have to subject X. I am going to take this 500 this side. Then it comes up 500 divided by 25 equals X into 20 cubic centimeters. Therefore, the volume of the solute is 20 cubic centimeters. Third type, the composition of a mixture as a mole fraction. What is this? The mole fraction of each component of a mixture containing only two components X and Y can be expressed as. Okay, now you think there is a solution or there is a mixture. In this mixture there are two components X and Y. Now they are asking me to find the mole fraction of X. Because they are asking me to find the mole fraction of X, I will take the amount of moles of X on top and the total amount of moles. That means in this mixture there are X and Y components now. That means the total amount is X plus Y. That I will take down. If they ask me to find the mole fraction of Y, then I will take the amount of moles of Y on top and down. It's the same. Now you can see for mass fraction, for volume fraction and for mole fraction it's the same method. That means if we want to find the mass fraction of X, mass of X came on top. If we wanted to find the volume fraction of X, volume of X came on top and the total volumes came down. Now here we have to find the mole fraction of X. So the amount of moles of X comes up and the total number of moles comes down. If, in the same way, if you want to find the mass fraction of Y, the mass of Y came up and the total mass down. If we wanted to find the volume fraction of Y, the volume of Y came on top and the total volume of the mixture came down. And if we want to find the mole fraction of Y, the number of moles of Y comes on top and the total number of moles comes down. Example 1. What is the mole fraction of sodium hydroxide in a solution made by dissolving 40 grams of sodium hydroxide in 180 grams of water? Here they are asking us to find the mole fraction. But They have not given us the number of moles of anything. They have given us only the masses. We'll see how we are going to do it. Here they are asking us to find the mole fraction. Mole fraction of sodium hydroxide. This is what they are asking. But they haven't given us the number of moles of anything. Here this solution is made by mixing sodium hydroxide and water. They haven't given us the moles of water. They haven't given us the moles of sodium hydroxide. But they have given us the mass of sodium hydroxide and the mass of water. They have given us the mass of sodium hydroxide as 180 grams. And they have given us the mass of water as 180 grams and mass of sodium hydroxide as 40 grams. Now to find the mole fraction, we should know the number of moles of sodium hydroxide and number of moles of water. How are we going to find the number of moles of sodium hydroxide and number of moles of water? We know the relative atomic masses of sodium is 23, oxygen is 16 and hydrogen is 1. And here we know relative atomic mass of hydrogen is 1 and oxygen is 16. First, I am going to show you how you have to calculate the relative molecular mass of sodium hydroxide. That is, sodium is 23, oxygen is 16 and hydrogen is 1. 16 plus 1, 17, 20 and 40. You get the relative molecular mass of sodium hydroxide as 40 grams per mole. And you know the mass of sodium hydroxide is 40 grams. Now I am going to find the number of moles of sodium hydroxide. To find the number of moles of sodium hydroxide, I am going to use this. I will show you. 40 grams divided by 40 grams per mole. I get 1 mole. 1 mole of sodium hydroxide. Here I took mass over molar mass. I'll tell you why. There is an equation, number of moles equal mass over molar mass. Remember this. Number of moles equal mass over molar mass. So to find the number of moles of sodium hydroxide, I took the mass of sodium hydroxide as 40 and the molar mass of sodium hydroxide as 40 grams per mole. Now I am going to find the molar mass of water or the number of moles of water. To find the number of moles of water, first I should find the relative molecular mass of water. H2O, hydrogen is 1 because H2, 1 into 2 plus oxygen is 16. Then I will get it as 18 grams per mole. Now I am going to find the number of moles of H2O. To find the number of moles, I should take mass over molar mass. The mass of water is 180 grams and the molar mass is 18 grams per mole. Grams cancel. I get it as 10 moles. this per mole comes up and becomes mole. Now I have found the number of moles of water as 10 moles and the number of moles of sodium, first I got it as 1 mole. Okay, now we have found the number of moles of sodium hydroxide and number of moles of water. We have to find the mole fraction of sodium hydroxide. Composition of mole fraction equal number of moles of sodium hydroxide over number of moles of the solution. Here we are taking number of moles of sodium hydroxide on top because we have to find the number of because we have to find the mole fraction of sodium hydroxide. We have found the number of moles of sodium hydroxide as 1 mole. And the number of mole of the solution. The solution contains sodium hydroxide plus water. That means 10 moles plus 1 mole. That is 1 over 11. The composition of mole fraction of sodium hydroxide is 1 over 11. Next type, composition of a mixture in terms of mass per volume. This is an example. 1 decimeter cube of a solution contains 10 grams of sodium chloride. Find the composition of sodium chloride in it in terms of mass per volume. Now we have to find the composition of the solute in terms of mass per volume. That means mass should come up and the volume should come down. Always in this composition, when finding the composition, total volume or the volume of the solution or the total volume comes down and the mass of the particular and the mass or whatever of the particular substance that we should calculate should come up. Here they are asking us to find the solute. So here the solute is sodium chloride. So we are taking the mass of sodium chloride on top. So the mass of sodium chloride according to this question is 10 grams. So I put 10 grams here. And the volume of the solution is 1 decimeter cube. So I will take it here, 1 decimeter cube. 10 grams divided by 1 decimeter cube, you get 10 grams per decimeter cube. Composition of a mixture in terms of moles per volume. This is the last method. Composition of a mixture in terms of moles per volume. When the composition is expressed in moles per decimeter cube, it is also known as concentration. So then we can get an equation like concentration equal number of moles divided by volume. I'll show you some examples. First example, a solution is prepared by dissolving 10 moles of sodium hydroxide in 5 decimeter cube of water. Calculate the concentration of the solution. They are asking us to find the concentration. That means the composition of a solution in number of moles per volume method. We have to find the concentration. Concentration equal number of moles over volume. The number of moles they have given us as 10 moles and the volume they have given us as 5 decimeter cube. So 5 2, the concentration is 2 moles per decimeter cube. Example 2. A solution is prepared by dissolving 117 grams of sodium chloride in 400 cubic centimeters. calculate the concentration of the solution. Here also they are asking us to calculate the concentration. The solution is prepared by mixing 117 grams of sodium chloride in 400 cubic centimeters of water. They are asking us to find the concentration. To find the concentration, we should know the number of moles and the volume. This volume we should know in decimeter cube. Now they haven't given us the number of moles of NaCl, but they have given us the mass of NaCl. First we are going to find the relative molecular mass of NaCl. Relative atomic mass of sodium is 23 plus relative atomic mass of chlorine is 35.5. We get the answer as 58.5. So now we are going to find the number of moles of sodium chloride. To find the number of moles, we have to divide the mass from the molar mass. So the mass of sodium chloride is 117 and the molar mass is 58 grams per mole. We get the answer as 2 moles. Now we have found the number of moles of sodium chloride as 2 moles. This is okay. Now this volume we have to convert this 400 cubic centimeter into decimeter. To convert this we are going to divide by 1000. Then we will get 0.4 decimeter cube. Now I am going to apply to the equation. Number of moles is 2 and the volume is 0.4 decimeter cube. I get the answer as 5 moles per decimeter cube. Preparing standard solutions. When preparing standard solutions, there are certain things that we should consider. I'll show you by doing 2 examples, and when doing these calculations we need to know these conversions. 1 decimeter cube equal 1 liter, 1 decimeter cube equal 1000 cubic centimeter, 1 decimeter cube equal 1000 milliliter, and 1 cubic centimeter equal 1 milliliter. Example 1. A solution was prepared by weighing 17 grams of sodium nitrate very accurately, dissolving it in a 200 cubic centimeter volumetric flask and diluting with water up to a final volume of 200 cubic centimeter. What is the concentration of this solution? They are asking us to find the concentration of the solution. Okay, now this solution is prepared by taking a volumetric flask of 200 cubic centimeters in volume, and they are adding 17 grams of sodium nitrate. And they are going to fill this with water up to 200, so that with the 17 grams of sodium nitrate, this is fully filled up to 250 cubic centimeters. not 250, 200 cubic centimeters. So they are asking us to find the concentration of the solution. You know, to find the concentration of the solution, we need the number of moles and the volume. So we have to find the number of moles of sodium nitrate. To find the number of moles of sodium nitrate, we have to find the relative molecular mass of sodium nitrate, NaNO3. The relative atomic mass of sodium is 23 and the relative atomic mass of nitrogen is 14 and the relative atomic mass of oxygen is 16 into 3. When we add all these together, we get the answer as 85 grams per mole. Now you know, to find the number of moles, we need to divide the mass by the molar mass. So I am going to find the number of moles of sodium nitrate. To find it, I have to take the mass as 17 grams and molar mass 85 grams per mole. Grams cancel off. I get the answer as 0.2 moles. Now there is 0.2 moles of sodium nitrate in 200 cubic centimeters of water. Concentration is, we have to find in 1 decimeter cube. So we will see how we are going to do it. Now amount of moles of sodium nitrate in 1 decimeter cube, that is 1000 centimeter cube. In 200 cubic centimeters, if there is 0.2 moles of sodium nitrate, then in 1000 cubic centimeters, how many moles are present? In 200 cubic centimeters, if there is 0.2 moles of sodium nitrate. In 200 cubic centimeters, if there is 0.2 moles of sodium nitrate, then how many moles are there in 1000 cubic centimeters? This is how we are finding it. When you cancel it off, you get the answer as 1 mole. That means 1 mole in 1 decimeter cube. So the concentration is 1 mole over 1 decimeter cube. Answer is 1 mole per decimeter cube. Example 2. What is the mass of potassium carbonate required to prepare 500 cubic centimeters of a 1 mole per decimeter cube potassium carbonate solution? They have given us the relative atomic masses as potassium is 39, carbon is 12 and oxygen is 16. Here they are asking us to find the mass. Let's see how we are going to do it. Now they are going to make a solution of potassium carbonate. 500 cubic centimeters potassium carbonate solution they want to make. They are asking us how many grams of potassium carbonate should we add to make this. Let's see how we are going to do it. First we have to find the relative molecular mass of potassium carbonate. We know the relative atomic mass of potassium is 39. So there are 2 potassium atoms, 39 into 2. Plus the relative atomic mass of carbon is 12 and oxygen is 16 because 3 are there, 16 into 3. When we calculate it, we get it as 138 grams per mole. That means in 1000 centimeter, that means in 1000 cubic centimeters, there is 138 grams of potassium carbonate. Now we have to find how many grams of potassium carbonate is present in 500 cubic centimeters solution. In 500 cubic centimeters, we have to find. That means in 1000 cubic centimeters, if there was 138 grams, how many grams are present in 500 cubic centimeters? In 1000 cubic centimeters, if 138 grams are present, then in 500 cubic centimeters, how many grams are present? You get the answer as 69 grams.